Hi everyone, this is Purnima Mahalingam and you're watching video lecture series on solar and wind energy. This is a new video lecture and you can see the upcoming videos in this various topic in solar and wind energy. Yes, come, let's go into the video. First, we are going to discuss about the evolution of wind power and history and overview. In this presentation, we are going to discuss about rich history of wind power, examination, signification, development over the year, and we will look into the current scenario both within India and globally. And along with the scientific principles that governs the wind. And key topic we are going to discuss in this presentation is about a Bill's limit, tip speed ratio, and the pitch control, all of which are fundamentals of understanding wind energy technology. By tracking these evolutions, we are aiming to highlight the wind power and critical roles in Indian today's energy scenario and landscape. First, we are going to see the history. So, in speaking about history, first we are going to discuss about early usage of a wind power. What is an early usage of a wind power? Here, the wind power has been utilized since ancient civilizations, and with the first use of windmill, Persia around 500 to 900 BC, aid of water pumping. And this is our first history of wind power. And the second is Industrial Revolution. In 18th and 19th centuries, SARS were a decline in the wind power with the rise of the steam engines. But the need of the renewable energy resurfaced in the 20th century due to the fossil fuel concerns. Now coming to the a modern wind turbine. So in late of 20th century marked the beginning of modern wind turbine, improving the efficiency and leading to large scale wind farm in 1980s. So primarily in the US and Denmark. This is the history of wind power and the timeline of wind power. Now come we can see the Indian and global wind energy strategies. So here we are going to see about global and wind in the wind energy strategies. So first, here in this you can see 50% of global wind energy capacities. So as of 2023, the global capacity has suspended 900 gigawatts, with China alone accounting of over 50% of the world wind power. So in world wind power, over 50%, which is accounting by the China. So 40 gigawatts of wind power in India. So in India, the installed capacity exceeds 40 gigawatts, aims for 60 gigawatts by 2022 and 140 gigawatts by 2030. And what is the economic benefits? The main economic benefits of thousands of jobs. So what is the main economic benefit? The wind sectors has generated thousands of jobs in manufacturing and installations and maintenance. So this is what Indian and global wind energy strategies market. Now coming to the wind physics. So what is wind physics? So basically we know that what is in wind physics. So what is it? Understanding the wind energy. What is it? Is wind energy is derived from with kinetic energy of moving air and the harshness using wind turbine. A small increase in wind speed can lead to the sustainable energy production. This is what an understanding of wind energy. So what process it takes? It's an aerodynamic of wind turbine. Aerodynamic of wind turbine process. Here the turbine blades. What happens? The turbine blades converts wind energy into mechanical energy through lift and drag forces, through the lift and drag forces. The shape and the angle optimize energy captures. So this is what an aerodynamic of wind turbine. So then energy conversion process, how the energy is converting. So here the mechanical energy generated by the turbine blade is converted to the electrical energy through a generator, which involves gearbox and converter. This is what the energy conversion process. Okay, this is about the wind physics. Now coming to the Benz limit, understanding the Benz limit. Here, what this is, the first one is definition of Benz limit. Here, the Benz limits indicate that no turbine can capture more than 59.3% of kinetic energy. That we know that. What is an impact of wind turbine design? So the engineers can use Benz limits to enhance turbine designs for high energy efficiency. Okay. What is the real world turbine efficiency is this? The actual efficiency ranges from 30% to 40% due to various factors. Okay, this is what understanding about the Benz limit. And coming to the tip speed ratio, here we can see it is what is the definition of tip speed ratio. Here the first is definition. The tip speed ratio is the ratio of the blade tip speed to the wind speed, crucial about for wind turbine performance. This is what a definition. What is an optical value? The optimal TS, a tip speed ratio value for horizontal axis turbine typically ranges from 6 to 10 of maximum size. Okay. Here, the control mechanism is in the control mechanism. Modern turbine use control mechanism to adjust the blade pitches and rotor speed, maintaining an optimal tip speed ratio. Okay, this is about the wind history and wind physics and what is the Benz limit and what is in the tip speed, what is the understanding of tip speed ratio. So here in the, by this we are ending this video and we'll be meeting in another video. Thank you so much for watching this video. Thank you so much.